evaluate composite functions. So the composite functions f open circle g, this is not a dot, this is open circle. So f open circle g, we call f compose g, is defined by f compose g at a point x is equal f open parenthesis, you have the g function inside, close. So you need to do a little bit practice. When you have f compose g, when you rewrite it, you will have the f outside, open parenthesis, g of x inside, close. When you have the function g compose f at that point x, when you rewrite it turns to the g function outside, open parenthesis, f of x stay inside, close. When you have f compose f at that point x, when you rewrite it, you will have this left-hand side f function outside, open parenthesis, f of x inside, close. So it has a pattern. You always let the left-hand side function stay outside, and the right-hand side function, it will stay inside at the first, when you rewrite at the first step. So that means this input variable x, it go to the function g of x, and then this g of x go to the f function. So the f function would be the outside, the most outer layer function, and the g function turns to the input of the f function. So we call this is f compose g. F is outside. When you have the g compose f, that means you have the x here, and then x is the f of x. Right? X is input of the f of x. And then this f of x turns to the input of the g of x. So the whole process will turn to g compose f. So your g function is outside. So we do the practice. If f function is 2x plus 7, g is x squared minus 1. Now we need to process f compose g and also do the g compose f. So we do the first one, g, f compose g at that point x. So first step is rewrite it. Rewrite it into the f function outside, open parenthesis, g of x, close it. Now, we always start from the inner function, the inside function. So the inside function, we have g of x. G of x is x squared minus 1. So I'm going to replace the g of x into the x squared minus 1, close it. Your outside still carry the f function. Now the whole question up here, you only has f function. G function is no longer there. So now you need to just deal with the f function. Look at the f function. F has 2x plus 7. This x is no longer just x. The x has changed into the x squared minus 1. So the way you rewrite on this step, my recommendation is 2x, keep the x space, 2x plus 7. So write down the function, f function first, but when you hear the x, you just leave it blank. So 2 something plus 7, right? 2x equals 7. Sorry, 2x plus 7. Now, you just replace your x with x squared minus 1. And then it will be very easy to solve it. Now you need to clean up. Distribute here. You will have the 2x squared minus 2 plus 7. So it turns to the 2x squared plus 5. So that would be the answer of this question. We do the other way around. G compose f at a point of x. So we rewrite into the G outside, f of x inside. Now we start from the inner function, start from f of x. F of x is 2x plus 7, so I write down the 2x plus 7, and the g function stay outside. So up here, you only has the g function. There's no longer has f function. Now look at the g function. G has x squared minus 1. Again, when you hear the x, I leave the x blank. So x squared minus 1. Now you replace the blank with 2x plus 7. So write down the 2x plus 7 into here. Now we need to simplify it. So 2x plus 7 squared, I mean you have 2x plus 7 multiply 2x plus 7. And then you minus 1. So when you distribute, you will get a 4x squared plus 14x plus another 14x. So you have plus 28x. Then plus 49. 49 minus 1, you will get a 48. So this will be the solution of the part B. Determine the domain of the composite function. So we look at this one. F of x is the square root x. G of x is equal to x minus 3. We need to find the domain of f compose g and the other way around. So we do the work. A, f compose g, so that would be f of g of x. Now we start from the gx. Gx is x minus 3. And you still have f function outside. Now look at the f function, it's a square root x. So I write down the square root sign. The x is a blank, right? Now I just replace the blank with x minus 3. If you look at the square root x minus 3, the graph of this one, it shifts to the right 3 unit, right? By transformation. It shifts right to the right 3 unit. So the starting point is no longer 0, 0. It has shifted to the 3, 0. So you have the curve like that. So the domain of this one is a bracket 3, 0 on the domain. We do the part B. B has G compose F, so I have the G function outside, f of x inside. Now we start from f of x. It's a root x. And your G stay outside. G function has x minus 3. So when I hear the x, I leave it blank, minus 3. Now I just replace this blank with root x. So we sketch the graph. This function has a vertical shifting, right? It goes down 3 based on the square root function, the parent function of the square root function. So this curve is no longer start from here. It shifts 3 down on the y-axis. So the starting point of the square root x start from here. But when you record the domain is the same from the 0, right? So you have the bracket 0, go to forever, open parenthesis. Okay, so we look at the example, the question here, these two that are from your web assignment. So f of x has a root x, g of x is x plus 1. Determine the domain of the composite function. So we do this one. This one is very similar like the example we just did. G of x, I'm going to rewrite to g of f of x. Now we start from the f of x, it's a root x, and g stay outside. Now your g function has x plus 1, so I leave a blank plus 1. Now I replace the blank with the root x. So this is a square root function. The parent function of a square root function, and you shift 1 unit up. So you have the square root x go up 1 unit, and then you go to the right forever. So the domain of this one would be bracket 0, then go to forever. Okay, so this part, we don't need to do the f of g. We just need to find a composite function. So we write down the root x plus 1. Oh, this is very easy. So that's it. Now we look at this one. F of x is 3 over x. G of x is the square root x. Find the value. G composes f at a point 27. Again, we rewrite this composition. G outside, f of 27 inside. Now we start from f function when x equals 27. F of x is 3 over x. Now we know the input variable changed to the 27. So I substitute the 27 to the bottom part. It gives me the 1 over 9. So now I'm going to rewrite the f27 is 1 over 9. So f27 is equal 1 over 9. And your g function is outside. Now the g function has square root x. So square root x. When I hear the x, I leave it blank. Now we substitute the 1 over 9 into the blank here. So 1 over 9 is the same idea. You have the 1/3 square. So now this power 2 cancel with the root. So it turns to the 1/3. So when you have a g compose f at 27, the result is 1 over 3. Now you can move on to Weber sign.